From ContainerDays, Hamburg, this video is proudly presented by Dux IT.
We'll start with the basics.
Hey there. Sounds like you might have just opened up your mic. No worries at all. If there's something specific you want to chat about or ask, just let me know.
Yeah, can you summarize this page for me?
Absolutely. So this page is basically talking about how Macquarie micro gateway architecture for their API management. Basically, they set up a dedicated API gateway for each domain. So each domain or set of services has its own little gateway. That way, they can isolate and control configurations more easily and avoid issues like noisy neighbors between services. In short, it's all about making
So the Gen AI is not hype anymore, as you all have seen. And Gen AI is everywhere now. Gen AI is no longer a buzzword. It's part of our daily lives now. Many company leaders say they have seen the clear benefits from using Gen AI, especially making their work more efficient and keeping customers happy. This shows that Gen AI is a valuable tool that brings real returns. It's now a key part of our businesses plan for the future. I am Saloni Narang. I am CNCF Ambassador, Docker Captain, and co-founder of KubeSimplify with 12 plus experience in IT.
And I'm Saiyam Pathak, head of DevRel at vCluster and CNCF Tag Operational Resilience Chair. And by the way, the demo that we just did was from a book that we got from here, so not pre-trained.
Yes. So I would like to ask all of you, how many of you are working with AI now in some form, like ChatGPT or etc.?
It should be everyone, come on.
Okay, so many of you are working with some sort of AI now. But AI is not new. It's not sudden, right? So from 1943, from artificial neurons to coining the term in 1950 to robotic and NLP in 60s, now we are in modern AI and the world where everything around us is surrounded by AI. AI is increasingly embedded in our everyday life, from healthcare to transportation. AI is rapidly moving from lab to daily life. In 2023, FDA approved 223 AI-enabled medical devices just from the last 6 in 2015. On the roads, self-driving cars are no longer experiments. Waymo, one of the largest US operators, provides over 150K autonomous rides each week, while Beidou, affordable Apollo Go robot taxi fleet, now serves numerous cities across China. Now, coming to the basics, what generative AI is. Generative AI refers to the type of AI that generate new context based on the data they have been trained on. It includes foundation models like GPT for text generation and stable diffusion models for image creation. Generative models such as diffusion models are developed for high-quality, diverse, and efficient output generation. These technologies provide a power of wide range of applications across industries, improving workflows and enabling innovative solutions. Challenges include like computational demands and quality data, while benefits include content creation, efficiency, improvement, and new data analysis methods. As you can see, models have become multimodal. What does that mean is it takes input in the form of text, images, audio, and code, and give output in the form of text, images, audio, and code now. These are some of the type of Gen AI. So we have text generation models like Cloud, Gemini, Llama, Mistral, diffusion and image gen models like Stable Diffusion, Midjourney, DALL-E, Ideogram. Then we have audio generation models like Whisper, Meta, and then we have video generation models like Sora. Veo also is one of them.
So again, we'll try to understand from the basics. This particular image that you are seeing is basically from on the right hand side is from the paper that was published by Google. Many of you would have seen it. It's the transformer stuff that got very popular, which is the basis, the backbone of LLMs as well. So why it is important, and before we move to the Kubernetes ecosystem, why AI on Kubernetes, how AI on Kubernetes and vLLM stuff, I think it's important to understand that the neural networks have been there for quite some time. And they have been doing pretty good tasks of identifying objects. You might have seen, like, the talks that were there 10 years back. It was like cats and dogs images, and the neural network is able to predict, okay, this is a cat, this is a dog. And it has been able to do those type of tasks very easily. But when it comes to text, which we speak, it has dialects, it has different meanings. The word-to-word mapping cannot be translated word to word. And this is where, like, there were some models on top of which people were trying to build something that can run in parallel. For example, there was this RNN model that was there. It's pre-transformer phase. So RNN used to take words in a sequence. Like, for example, if you have welcome to ContainerDays, that will be read in a particular sequence. And if it was to be translated, and by the way, the attention is all you need paper that was published by Google was primarily first for the translation, like for the translation of text for different languages. So it was in the sequence, which is why it was difficult, because RNN had the problem of, for the long context windows, RNN has had the problems like it didn't have a particular order in which the data is going towards the neural network to train a particular model. So this transformer revolution, which we call the backbone of LLMs, came out as part of the paper. Attention is all you need, and that was kind of the benchmark that entirely changed the whole landscape. Like, we know, or many of us are very hyped up after the ChatGPT wave, but the researchers and all, they were hyped up before the ChatGPT wave and after the transformer wave, because now they thought the possibilities, just like we think the possibilities with this whole LLM ecosystem, that we are able to build AI agents, and everything will be autonomous, automating everything. So transformer used the key things in transformer, this particular model is, one is attention. So it is able to identify which words you should pay attention to. Very simple. Now, attention also was there pre-transformer. What transformer, when this paper released out, was self-attention. Like, you have grammar, you have synonyms. So it's able to learn all those things. So it's able to get that self-attention. That was one of the key things. And the key idea was, when reading the text, for example, the sentence like Kubernetes runs on clusters, the runs strongly connected to Kubernetes, and on connects to the cluster. Transformer is able to do that in parallel, so you can train more amount of data with better hardware, with respect to when it was RNNs, where even if you give more GPUs, you won't be able to train that amount of data. So this parallelism is what makes transformer fast and scalable, and this is why they are the foundation and the building blocks for LLMs. Now, LLM stands for large language model, and this is very simple. The idea, like Saloni has already mentioned, like, generating text, or very simple terms like predicting the next word. And it has been happening. If you remember, when you used to do Google search pre-ChatGPT, if you write happy, it used to give some suggestions like birthday is the next obvious one that people would use, or time-based when there is some festival, Halloween and stuff. It used to give those suggestions. So basically predicting the next word, it's basically the autocomplete. And for example, if you have, again, Kubernetes runs on, most predictable output would be like nodes, clusters, obviously not the bananas. So LLMs, you can essentially is a giant autocomplete machine that is powered by transformer trained on huge amounts of data. Now, when we talk about huge amount, it's literally very huge. We are talking about large petabytes of data, a chunk of internet on which these are trained. Now, let's zoom into the GPT and what we mean by the foundational models. So GPT, if you know, that's good, but if you don't know, GPT stands for Generative Pre-trained Transformer. Transformer is in the name. This is how relevant that is. This is why I'm re-emphasizing on why Transformer was one of the key milestones. Very good paper. Attention is all you need, that everyone should kind of read before getting into this AI hype. So generative obviously means generating new text, and pre-trained means that it is being trained on massive chunk of data that is available on the internet. And then transformer is the architecture, which is the attention-based model. Now, GPT is what we call something is the foundational model. So this is, now you have the foundational model. What we do is, what that means is, now we have the huge data set. Now we have the huge foundational model. Now we can go use case wise and we can fine tune it. So we can fine tune it for chatbots. We can fine tune it for summarizer or summarizing the documents and code assist. So those can be different things where it can be summarized. So instead of training new models from the scratch, we built, it basically means that there is one foundational model, and then we keep fine-tuning as per the specific use cases. This is why the GPT and the similar kind of models, the foundational models, they are general purpose engines, like the search engines or the general purpose engines for the language. And before the model can process text, it actually chops that into the tokens. For example, if you see welcome to ContainerDays 2025. So this is taken from, I think, the GPT-5 or 4 tokenizer. So there is a concept of token and tokenizers. So every sentence is broken into different chunks. Every token will be assigned a particular number before it goes to the neural network. So this is what happens. Like welcome to ContainerDays is 7 tokens, 30 characters. That's how it is mapped. And that's what goes inside. And for another example, like Kubernetes rocks or whatever that is, it will be broken into different. It can be punctuation, spaces. Tokenizer can split it into different Lego blocks, you can say. Inside the model, there is something which is called parameters. So you might have heard of, this model is coming out as 7 billion parameter model or 30 billion parameter or 80 billion parameter model. So this is very, very common term when you go on Hugging Face. So Hugging Face is just like, GitHub, but for all your models which are there. And every model will have billions. And the lesser the parameters, the less will be the size of the model, less will be the compute that it will be consuming, and faster will be the result, but lesser will be the accuracy. More the parameters, more compute it will require, and more will be the accuracy. So it has a bunch of different concepts, like it has weights, it has all the other things inside, biases, weights, and bunch of other things, and that leads to whole parameters. For example, GPT-3 has 175 billion parameters. So that's how the B comes in. So we learned about transformers, we learned about the foundational models, we learned about in the previous one, the tokenizer, and we learned about the parameters as well. The last concept, before we move to the Kubernetes world, is the context window. So context is very important. If you heard Kelsey's keynote yesterday, you saw, right? If you do not give the context, it tries to help, but it's useless. It hallucinates over there. But when you give the right context, it gives you the right output. Now, how do you give the context? In terms of more text, in terms of PDF file that you attach, or whatever it can be. So there is a context window that you can actually give. Like you can't give infinite amount of data to a LLM. There is a finite context window over there. So it's basically the model's short-term memory, the maximum amount of text that it can look at when it is predicting the next word, paragraph, sentence, and stuff like that. So putting it all together, you have all the stuff that you have seen on the right. So you can start with some input. The tokenizer splits that into different chunks and tokens. These tokens goes into the transform model, which then uses attention algorithms and billions of parameters that is assigned to the model and process that. The model predicts the next token, and then one at a time, and it gives back the prediction. So when you interact with ChatGPT, it's basically generating one token at a time very fast until you see the complete sentences, which is why you see one coming up after the other. And if you go little back in time, a few years, you'll see it was taking some time to just, you would have, if someone is typing at 2x, you saw that in terms of the output that you received. But now it's pretty fast. Like Gemini just gives you, boom, the output comes immediately over there. So giant autocomplete machine is working, and we all are kind of using it. That's where we stand with the LLMs. I hope the basic concepts of the LLMs, how and why is kind of clear now.
So now we know what generative AI is, what LLM is. Now you must be wondering how Kubernetes fit into the AI ecosystem, right? So let me tell you, OpenAI, the AI research lab behind technologies like GPT, ChatGPT, and DALL-E, relies on Kubernetes to manage the vast infrastructure required to support to their large-scale machine learning workloads. So Kubernetes is a key part of OpenAI's ability to scale their operations efficiently across both cloud and bare metal environments. Kubernetes is the top orchestration system already in place, and now with the organization banking on Kubernetes to run AI workloads, it makes even more sense to use Kubernetes. Even the Kubernetes community is trying to do a lot in this space. Let's try to understand what the community is doing and why it matters for the AI ecosystem. So let's talk about something that's changing the game for AI workloads in Kubernetes. It is DRA, Dynamic Resource Allocation. Traditionally in Kubernetes, we used to pre-allocate GPUs or high-performance storage to pods, even if they don't need it all time. That leads to waste, over-provisioning, and frustrated scheduling experience. DRA flips the model. It lets your pod request specialized hardware, like a GPU or a fast volume at runtime. So when they actually need it, now you can request specialized hardware. Think of it as on-demand resource allocation for AI, similar to how serverless works, but for hardware accelerators. And in the world of LLM inference and GenAI, this is the kind of dynamic flexibility is exactly we need to run smarter and more efficient workloads. As AI workloads explode in complexity and diversity, Kubernetes scheduling needs to evolve. That's where DRANet by Google comes into the picture. DRANet is a new way to handle high-speed networking like RDMA for AI ML workloads in Kubernetes. Instead of using complex plugins and custom scripts, DRANet lets you set everything, like turning off your eBPF or tuning network cards, right in your Kubernetes YAML. It's fast, it's secure, and now in beta, built using DRA, Dynamic Resource Allocation feature. It's open source, super lightweight, it's under 50 MB, and runs safely without extra tools. If you're working on high-performance AI or HPC workloads, DRANet can simplify your networking setup. Now coming to the next feature, NUMA, which stands for Non-Uniform Memory Access. As AI and data-intensive workloads continue to push the boundaries of compute infrastructure, understanding how Kubernetes schedules pods in relation to the underlying NUMA topology becomes very critical. NUMA, or non-uniform memory access, refers to how CPU cores and memory are physically structured in multi-socket machines. Each socket has its own memory, maybe local memory, and accessing memory outside that socket is very slow. In Kubernetes, if a pod is scheduled without NUMA awareness, it might get placed across cores that span multiple NUMA nodes, causing cross-socket memory access, higher latency, and cache inefficiency. This is especially painful for LLM inference, training jobs, and low latency AI inference, where performance drops just from poor core memory locality.
All right, just to sum up before we move to inferencing, what we have learned till now is what is generative AI, that it's not a hype anymore, it is mainstream. We have seen that it can easily summarize a page that is given in a few seconds and tell you what is there on a new piece of book. So it is mainstream, being used everywhere. You are using, I'm using, people are using it for code generation, content creation, and whatnot. We have seen what powers this whole AI wave, the tokenizer model, what are tokens, what is a tokenizer, what is a transformer, what is GPT, what are foundational models. Now comes to a very interesting part, which is the inferencing. Now, inferencing means when you are accessing a particular AI model, like you are inferencing, you are chatting with your ChatGPT or a particular endpoint or Olama and interacting with that. So inferencing is hard at scale. So most of us start by running LLMs in small demos or POCs. That's what happens. But when we move to production, the few of the issues that happens is the two critical ones is KV caching, and another one is the GPU underutilization. So the KV caching, basically it means like every new sequence storing token level history and memory kind of goes out as quickly as the user, the new number of users, or the prompt, the number of prompt that increases. And the second bottleneck, like I mentioned, is the GPU node, GPU underutilization, and GPUs are expensive and also scarce. Like there is a scarcity and they are expensive. So some of the workloads are like some of the inputs are variable in length. So as they go, it changes. Like some stop early, some some take some long time, which makes the batching kind of difficult in this particular things. These are the two main issues. The LLM inferencing becomes a slower and expensive operation in production. This is where a vLLM comes in. So vLLM is open source project. Yes, it is. You can see from the GitHub stars already that it's an open source project out there. Engine designed specifically to run the LLMs, the large language models, efficiently at scale. So it's mainly the inference engine to run the LLMs at scale. It obviously tackles the two problems, which is why I discussed that, KV caching and the GPU underutilization with its architectural innovations. And if you look at the developer community, you will be able to see that in the developer community, vLLM has gained a lot of traction since 2020, 2022, 2023 timeframe. And it is showing that it is a lot loved by the developer community, and which is why it is outpacing some of the others on the star dashboard, whatever it is. So this is how critical inference optimization has become, and it is obviously heart of MLOps. And when you talk about vLLM plus Kubernetes, so when we talk about vLLM and Kubernetes in this particular space, we combine both of them. So what we are combining over here is the scalability, because vLLM ensures that inference runs efficiently and serving more requests at lower cost and better utilization. And Kubernetes takes care of the GPUs, like scaling pods up and down, scaling nodes up and down, hardware stuff, abstracting the hardware details. Like it has all the features that Saloni just mentioned, DRAnet, multi-NUMA, device plugins. All these things are there that helps with the ecosystem in providing that AI infrastructure layer, whether it's cloud, hybrid, or on-prem. This is how the inferencing becomes production ready with vLLM and Kubernetes. One more thing I would like to highlight over here that makes vLLM unique is like these four, obviously, the high throughput, paced attention. So we haven't talked about paced attention, but this is the key thing that makes vLLM unique. So paced attention is something that is a smart, in a very nutshell, like it's a smart memory management tool, and it is obviously by the OS, like the traditional operating system concept of paging, and It reduces the memory waste, allowing the longer text and more concurrent users, which is what was missing when we talked about the KV caching. Continuous batching, that was another problem. It keeps the GPU busy and improves the responsiveness. And vLLM compatible with the OpenAI API. So it gives you the endpoints that are compatible with OpenAI. So you'll be able to have access those endpoints easily. And making the learning curve, or basically making the adoption curve, pretty easy. This is the architecture. If you look at the vLLM under the hood, there are a few key areas. One of them is model server, which loads the model into the memory. Second one is the page attention technique inspired by the OS virtual memory to break attention cache into pages, making memory use efficient, and then long-term dynamic request. And third is the continuous batching engine that serves request in the real time instead of waiting to form large batches. This keeps busy GPUs very busy, which is good because you pay a lot already for the GPUs. Finally, there is also the block-wise memory management that avoids the fragmentation in the KV cache. And together, everything combined makes vLLM more efficient than the traditional serving libraries out there. So we'll now quickly do a demo of what I have. So vLLM needs a GPU, by the way. I don't have a GPU, so I'll be doing this particular demo on a Kubernetes cluster. Okay, let me escape this. Yeah, I'll be doing this demo on a Kubernetes cluster, and let me just mirror my screen. Okay, cool. So it's a CPU-based Kubernetes cluster. Obviously, I don't have any GPU, but what I have done is I have created a GPU-compatible, compatible vLLM interface kind of thing. So right now, I also have a pod that is running, which will be able to do if it's running. So I tested this 5 hours ago. 5 hours ago is a decent time, right, to test stuff that it's working or not. This is the application. vLLM compatible API server, because when you directly use the vLLM server, it needs a GPU. But I have the CPU. Either I have to build from scratch, which I didn't like. So I created this particular compatible API server. So simple, fast API server. It is using GPT-2 as the model from Hugging Face, and just the tokenizer, regular tokenizer stuff over here. And these are the endpoints. So /v1/models, the OpenAI compatible model. So here we have GPT-2, and then /v1 completions, another OpenAI compatible endpoint /v1 completions. This is the text completion, and then you have then is the response stuff. And you have the chat, yes, /v1 chat completions as well. So these are the OpenAI compatible endpoints. So this is the server which is running on port 8000. If you want to build this, you can build this using the Docker file, pretty simple Docker file over here that is doing all the stuff. And then you have the deployment. So this is what I have already deployed. So I built this, I post this image, and then I am running a simple deployment out there along with a service, which is a load balancer. So this is what I have done already, and you can see a pod is running. These are heavy images, so if I do it from scratch and do not end up on the same node, it takes time. So let's see if I have, and if this is the right service, get SVC. This should be the right endpoint, 178.1. Yeah, that's the right endpoint. So we'll just curl. This is a GPT-2 model. So I actually have specified also, right? So model GPT-2 message, and it gives ContainerDays. And I don't know what it gives for ContainerDays though. Again, the smaller the model and without context, it tries to help, but what is maybe Kubernetes, at least it should be giving some decent output. That's pretty bad, right? So that's what. So without context, without anything, this becomes very lame. Like whether we should use it or not use it. But when you have GPUs, when you write the RAG applications, when you give this is why the RAG applications were powerful, right? Because when you give them the context, when you give them that this is the context file, this is my PDFs, these are my stuff that you have to go through, search, and this is the data set that you are already having. It adds context and it gives meaningful responses, which should help. Else, like Kelsey mentioned yesterday as well, right? Go here and go there doesn't make any sense. You're just trying to help without being helpful over here. So in a nutshell, what we discussed today is it was the basics. So I hope you got the basics of what LLMs are, how LLMs work, based on the models which are there, based on the algorithms which are there, then tokenizer, transformer, the whole attention, self-attention stuff, and then what is GPT, what is LLMs, what is vLLM, and why Kubernetes for these set of workloads. Already we have seen that Google announced some time back that you can scale their clusters to 65,000 nodes, although they are not using etcd. They swapped that up with Spanner. Recently Amazon announced that you can scale up to 100k nodes. That's the scale that we are looking when we talk about building AI infrastructures, because AI infrastructures will require a lot more compute than we even imagine. So 100k is coming up, and then there will be 200k. But again, the traditional components won't fit in there. Every cloud provider is doing their own implementations, their own customizations, and then they are building on top of that to provide you that scale. And the next wave or the next trend that is coming, or not even trend, which is in implementation phase, is bare metal GPUs, because everyone wants their data to be safe. We have seen like sovereign clouds presence over here, everyone talking about sovereign clouds. We do not want, or the organizations do not want their data to go out of anywhere. So this is where you have people are buying those NVIDIA boxes. They are keeping them in the data center so that they can run the open source models and then train it using their data, and do not send that data anywhere else. In that also, Kubernetes plays a very important role, because you can now have big Kubernetes clusters, and you can use different tools, techniques to give that to your teams. Because when you create those Kubernetes clusters, you have different set of challenges, because now you're using native Kubernetes and there is no distribution like from EKS or GKE that you can use directly. So you have to do it yourself. You have to plug and play. You have to use stuff like Chi scheduler, NVIDIA operator. Chi scheduler is pretty important in terms of scheduling, I would say. I'll talk about it tomorrow in my talk. 13 Kubernetes hack. I gave away one Kubernetes hack, which is this scheduling, because the traditional scheduling was not built or meant for these particular workloads. So while reiterating what Kelsey mentioned, while not everyone needs to be on the AI hype, but I do feel that whenever there is a new technological shift that happens, there is one good thing that happens is people think from different dimensions. People in the Kubernetes community were not thinking from these dimensions, but now they are thinking. They are building stuff like Saloni mentioned, DRA and all sorts of things. So they are thinking from different dimensions and making sure that our system that we want to make boring or Linux type or fundamental becomes the system that is being used by the AI for the AI workloads and stuff like that. So I hope you got something out of this talk. Thank you so much for coming in, and see you tomorrow at my talk as well.
Thank you, Saiyam. Thank you, Saloni.
And that was our daughter who just invaded the stage, which is okay, I suppose.
We have one question before you leave. As an MCP developer, what are the most important LLM model attributes I should keep in mind?
I think MCP, Model Context Protocol, is something that is gaining a lot of traction. I don't know if you want to add anything to MCP. I think Docker is doing a lot in bridging the gap on creating those MCP servers. Everyone is trying to create that MCP server so that in all of your workloads, in all of your AI applications, when you are trying to connect or trying to interact with any of your, like, for example, if I want something from internet, so there is an MCP server called fetch. So it will call that particular MCP server, fetch the data in the required format. Then you have MCP server for, I don't know how many, 200 or maybe thousands of MCP servers
in
out
Docker
there.
Desktop, there are so many MCP servers available to connect. 200 plus now, I think.
Yeah, I think Docker is doing a great job in bridging the gap for the developers, especially, and how you can use and build those MCP or use those MCP servers for your applications.
Thank you. There's another question about an LLM comparison. Do you have some words about that?
Yeah, Olama is basically for running, like, it's not meant for inferencing at scale because it doesn't have any specialized algorithms that does help with KV caching or GPU utilization. It's just a way to simply run an open source model locally, or, yes, you can run on your Kubernetes cluster as well. There's a simple Olama deployment, and you can run an instance of Olama if you just want a simple RAG application to access that. But when you talk about inferencing at scale, when you talk about millions of requests coming in, or different set of instructions, because for example, every code completion request that comes in, so you need the next code completion response immediately when you type what should be the next one. So that's where I think this caching will be more important. vLLM would be good. But there is one interesting project that I want to touch, which is called LLMD. This is by Red Hat that they recently announced. LLMD is also built on top of the same principles, but it is more Kubernetes native. It is by Red Hat. It is open source, and it is also in the inferencing space, like how to do inferencing at scale using LLMD. So that is a project that I am also exploring. So I would, wanted to touch upon that.
Thank you.
Thank you. Thank you so much.
From ContainerDays Hamburg, this video is proudly presented by DuxIT.